1.
In this video, we're going to learn about how to graph compound inequalities. See the description on the YouTube channel for timestamps about where to go in the video. So before we get started, we just got to make sure we know our inequality symbols. We have the greater than symbol, greater than or equal to, less than, and finally less than or equal to. So make sure you know what the symbols are, what they look like, and what they mean. Some key ideas for graphing these inequalities is to know if you need an open or a closed circle, which direction you should shade, and since we're talking about compound videos, you're either going to have an and situation or an or situation. So an analogy that I think is helpful is to think about when you want to go hang out with your friends and your parents tell you what you have to do before you can hang out. So my parents would say, like, you have to clean your room and you have to do your homework. So what that means is if I want to hang out with my friends, I have to make sure that I've done both of those things. Whereas if my parents say, you need to either clean your room or do your homework. So I could clean my room or I could do my homework. And it would be fine, right? I wouldn't have to do both. But and means both requirements have to be met, or is one or the other. And so hopefully that analogy helps you when we look at these problems. So first we're going to look at some graphs that are already taken care of and write the corresponding inequalities for them. So here we have an open circle that goes off to the left and another open circle that goes off to the right. So this is a case where x is going to be one thing or another. So let's go ahead and write the inequality for that. So I know because I have an open circle, I'm going to need either less than or greater than as the symbols I use. And so in this case, I know that the circle's around -3 and that x is going to be numbers less than -3. So x is either less than -3, which is this piece, or x is greater than 5. And so that's the example about the or. So x is one or the other, and that's exactly how we would write it. In this case, we see two different pieces going off in opposite directions, which means we have another or situation. But this time we have closed circles. And so I see that we have a closed circle at 5 going off to the left. So that means x could be less than or equal to 5, or x could be greater than or equal to 9, because we have this piece here that has a closed circle at 9 and it goes off to the right, which are numbers bigger than 9. And so that's this graph's inequality. So this inequality is a little bit different because now we have two open circles, but instead of going off in opposite directions, they're connected. So this is an example of an and situation. So we know that x is going to be greater than -8, and x is going to have to be less than 3. I know we're going to be using the less than and greater than symbols because we have open circles. So x is greater than -8 and x is less than 3. So it has to be both of them. So what we can actually do is to write it as one inequality. -8 is less than x is less than 3. So we have the -8 is less than x, which means x is bigger than -8, but it's also less than 3. So you have to meet both requirements. So here we have another example where it's an and situation, which we can recognize because instead of the shading going off in opposite directions, there's just one piece that's shaded between two circles. But this case is a little different because we have the one open circle and one closed circle. So we know that x is going to have to be greater than 0 because it's going off to the right, and we have an open circle, and x is also less than or equal to 11 because we have that closed circle being shaded off to the left. But we don't want to write it as just like two inequalities like this. What we really want to do is say 0 is less than x, which is also less than or equal to 11. So if you don't need to write the previous statement like we did up here, like, don't write that. This is what we want. But if you need to write this step, please do so. So that's kind of the gist for looking at the graph and writing the corresponding inequalities. So now let's practice graphing ourselves. So this problem wants us to have x is less than or equal to 3, or x is greater than or equal to 5, which means we're going to be having the two ends going off in different directions. So I'm going to just start with the first one I see. We want x to be less than or equal to 3. So I need a closed circle at 3, and then the numbers less than 3 are going to be off in this direction. Make sure to put that arrow, meaning that those are going to be all the numbers less than 3 or equal to 3. We also want the other piece where x is greater than or equal to 5, so I'm going to put that closed circle at 5, and show the numbers that are bigger than 5. And so that's the corresponding graph to that compound inequality. So here we can see by the way the inequality is written, -8 is less than or equal to x less than or equal to -1, that this is an and situation. So I'm going to find -8 and put a closed circle. And we also want to find -1 and put a closed circle. And we're saying that x is any number between those two numbers, or x could be like -8 or -1. So to show all those possibilities, we just connect those points, and that's how we graph this inequality. So here we have another or statement. The or statement's pretty easy to recognize because they say or. So we know we're going to have two pieces going off in opposite directions. We want x less than or equal to -9, which we actually don't even see on this number line. So like we're going to have to just add that in here, which is totally fine. We want a closed circle here. And we want to say x is less than or equal to -9. So we're going to be going off to the left. Or x is bigger than 11. So we'd have to go off 9, 10, 11, and then go off to the right. And I just made a careless mistake. We want x to be greater than 11, but it actually can't be 11. So we actually need an open circle. Okay, so we have that open circle here, 9, 10, 11 added in here. And that's how we graph this compound inequality. Obviously, if you're graphing on your own and you're not provided a number line, you can create whatever number line you need. And in this case, like I just accidentally messed up. And so I just extended my number line as needed. Not really a big deal. And if that happens to you, just extend as needed or create a new number line. We're going to look at one last example, -5 less than x less than or equal to 0. So this is an and statement. So we want -5 to be less than x, and we want x to be less than or equal to 0. So we need to find -5 and put an open circle there because we have a less than symbol. And then less than or equal to means we got to put a closed circle there at 0. Then we're going to connect those two circles, and that represents all the solutions to that inequality. So the gist here is that we got to know if we have an open or closed circle by looking at our inequality symbols. If you have less than or equal to or greater than or equal to, you're going to have a closed circle. If you have less than or greater than, you're going to have an open circle. You need to know which direction to shade, and you also need to know if you're going to have an and or an or, and that's going to help you know if the points should be connected or if you're going to just have two opposite ends going on. And that's how you graph compound inequalities.